So in this video, we're going to discuss a few considerations that should be taken into account when designing augmented reality applications for construction, manufacturing, and fabrication, and how to maintain the best possible user experience for frontline workers who will be using the HoloLens 2. The best applications of augmented reality really are simple, reliable, and integrated into existing work processes as much as possible with minimal disruption for the end user. So a few things that should be taken into account are things like model format, legibility, scale, reachability, and orientation. Considering model format, it's important to ensure that where possible, you use the minimal amount of graphical information to display or communicate a task to an end user. So in this example of the brickwork that we developed for the Royal Hobart Hospital project with Allbrick in Tasmania, rather than showing a solid brick model or a textured brick model, which was sort of photorealistic like bricks, instead we showed colored line work outlines of only the top face of each brick and small text labels describing the brick type, because there are several types of bricks. This was the minimal amount of information required for the bricklayers to accurately locate bricks in these curving walls using the holographic guide. If we could have taken out any more information, we would have. The rest of the plan that you see here is used really just to verify that the model of the bricks is located in the correct position on site. So we can do things like visually aligning the plan of the walls here with the existing conditions just to quickly visually verify that things are in the correct location. Ensuring that the model is legible to the end user is really critical. So for instance, showing things like existing grid lines or wall edges in plan can assist with legibility by making sure that an end user can just perform quick checks that the model is in the right spot. But showing any additional holographic information, especially when holographic information is outside of the scale of the room that you're currently working in, can become confusing to the end user. So if you're using a holographic model that's around the scale of a room, we generally recommend not showing any holographic information beyond the scale of that room, just because it by default won't be occluded by the physical space, and so you'll see the whole building like an X-ray, as well as the content that you're needing to focus on to perform a particular fabrication task within your current work environment. So where possible, break models up into room scale. This can improve legibility for the end user. Considering model scale is also fairly critical. So it's generally a better user experience to display models at smaller scale than it is to try to view entire buildings at one-to-one in augmented reality. This is just because of the limitations of the current HoloLens 2 display. You can easily create screen door effects where you can only, it appears as if you're looking through a small screen at some much larger holographic content, which can be confusing and distracting for the user and reduce immersion if you're viewing very large models. And also you get depth flattening of very large models. So objects which are far away, it becomes difficult to read those at different depths just because they're all flattened into a single focal distance. So if your goal is to create an immersive experience of a very large model, a building scale model, it may be a better application for virtual reality than it is for augmented reality. When designing holographic experiences for frontline workers, where you might be performing set out, layout, assembly, or QA using a holographic model, it's critical to maintain reachability of the holographic model. So this is a little bit difficult to counterintuitive to explain, but holographic models are going to be most reliable when they're at about arm's length from the user, because this is the focal plane onto which those models are rendered. So when you're looking at a holographic model which is about arm's length away, your eyes are going to be able to correctly estimate the depth of that holographic model. And so they will appear in the correct place. When you're looking at models which are further away, um, those models may appear in an incorrect location, even though they are actually in your digital holographic model, they'll be in the correct location. They'll appear in an incorrect location just because your eyes are looking at a rendering, which is, maybe 30 millimeters from your eyes. And even the tiniest imprecision in that rendering on the HoloLens stereoscopic display can become the appearance of quite a large sort of imprecision in location once that position is extrapolated at a greater distance from your eyes. So where possible, maintain reachability of holograms. If they're going to be used as guides, you should be able to walk up to the hologram, hold out your arm, and create the experience of basically touching that hologram. At that point, you'll know that the hologram position is going to be reliable. You can use it for placement tasks. But don't design experiences where you need to be judging the location of something which is greater than an arm's length away using a holographic guide, because the position is not going to appear reliable to an end user. Lastly, it's important to consider model orientation in your application. So where possible, holographic models should be oriented to physical objects. So if you're laying something out on the floor, the hologram should be oriented on a floor. If you're constructing layers of brickwork, the layers of the holographic model should align or be oriented to the surface of the current course of bricks. This makes them far more easy to use as guides, because your brain is going to be able to easily work out the depth of a hologram by using the depth of the physical object that hologram is oriented to. So where possible, try to avoid holograms that are freely oriented in space. It can be very difficult to judge depth correctly. It's much, much, much easier to follow a holographic guide if that hologram is oriented or aligned to an existing physical surface, like a wall or a floor, or the surface of something which is being constructed. Okay, in the next video, we'll talk about preparing a 3D model for augmented reality.